We are beginning lesson 5.4. So we're still in the chapter 5. This is the last lesson, I believe, in the chapter. And this one is talking about systems of linear equations. And I'm not going to read this word for word. If you want to do that, that is fine. But I'm going to go ahead and jump over to page 173 and just show you this example. So, example 1 in the textbook says to solve a system by graphing. And the two equations that we want to use are right here. Right in there. So I'm going to bring those down. I think I'm just going to take a screenshot so I don't have to remember them. And just bring them down here to the bottom at my graph. And so I have this nice coordinate plane here, and here are the equations that I need to graph. Now, the first thing you want to do is to write your equations in slope-intercept form. So step 1, if you have a system of equations, is to put them in slope-intercept form. And let me just review what a system of equations is. A system of equations consists of two or more equations with two variables. So we have an x and a y, and we have it in two different equations. So this is called a system. All right, this is the system that we want to solve, and we're going to look for a solution to this system. And there are different ways to find the solution. They want us to graph this particular one. So I'm going to first get my equations into slope-intercept form. And remember what that looks like. Slope-intercept is your pattern where y equals mx plus b. Now in this first one we have 3x plus 3y equals 9. So remember, we put what we want on top and what we have on the bottom, and then we have to move things around. So b is fine right there. We have a constant. And then we have the y term is in the right place. Because remember, you can have, it doesn't matter if you have a number in front of y at the moment, it's going to in a minute. But the mx, the slope x term, needs to be on the other side. You can see it's on the wrong side. So I'm going to minus 3x here and minus 3x over here. So it's canceled here, and we've moved it to the other side. So now the slope piece is there. So let's simplify. We're going to do 3y, still on this side. Now I want mx to come first, and that's a positive 9. We're getting there, but we need plain y. We can't have 3y, we need 1y. So let's divide by 3 here, here, and here. So this will cancel. I'm left with y equals 3 into negative 3 is negative 1, x plus 3. And officially that would look like this. Okay, so I've got that equation in slope-intercept form. Now I need to do that for my other equation. So again, I'll draw the pattern of what I want. So we want y equals mx plus b, and we have standard form 4x plus 2y equals 8. I'll tell you what, let's put that 8 under the constant because that's where he matches up. So we have b right there. We have y and 2y. But again, that x term needs to move over here. So I'm going to subtract the 4x from this side and subtract it over here. So we cancel that. And we're left with 2y negative 4x plus 8. But again, we need just y. So let's divide by 2 to all terms. That's very important. And so we're left with y equals negative 2x plus 4. So now I have two equations that I will be graphing on my coordinate plane. But to do that, I need some points. So let's bring a table of values in. I'm going to use a header row and then 2 coordinates. So we've got x and y. And I'm going to use the intercepts. I'm going to use 0 and 0. And then let's see what we get for the other pieces of the puzzle. Let me copy that. I won't have to draw it again. We'll do it over here in just a minute. So right here, I'm going to use the intercepts to make my coordinates. So I'll say y equals negative x plus 3. So in this case, y equals negative 0 plus 3. So y equals plus 3. And then in this one, I know the y coordinate, so I'll say 0 equals negative x plus 3. Okay. And I'm going to move my x, so I'll add an x here and add an x here. So I'm left with x on this side and 3 on this side. And then I'm going to graph this particular one. So I'm going to say 0, positive 3. That's here. 0, positive 3. And then 3, 0. And go ahead and draw the line in there. It has a negative slope. We knew that because the x is negative in our formula. Let me try one more time to get it straight. That's close enough. So this one, I think I need it to be bigger. You'll see why. Let's try that one more time. So I'm going to bring that the full length of my coordinate plane. There's a reason for that. I'll promise. Okay, that's as close as I can get it, I believe. All right, so that is the line that we just did. I'm going to go ahead and label it just so I can keep track of it. This one is y equals negative x plus 3. So that is the line for that equation. Now, let's do the other one, the other part of the system. So this one is y equals negative 2x plus 4. So it will also have a negative slope. And I'm going to plug in that negative 2 times 0 plus 4. So that leaves me with y equals 4. And then do it one more time to see what you get down here. And this time y is 0, negative 2x plus 4. So I'm going to move the 4 and cancel. Actually, no, I'm sorry. I need to move the x. So I'm going to add 2x to both sides and cancel. So I'm left with 2x equals 4. Then divide by 2 so that you isolate the x and you get a 2. So 2, 0. And then I'm going to graph this table of values. So 0, 4 is up here. And then 2, 0 is right here. And here comes the line right down through here. It's the thinner line, but we can't see it, can we, if I make it thin? Let's make it a little darker. Okay. All right, one more time. Amanda, get it right. Not even close. My graph is too small, really. Let me try to enlarge it and see if I can hit it a little better. That didn't work, guys. This may not work at all. I can show you what I'm trying to hit, but it's not working to snap to. All right, that's close enough. What you're interested in is where the lines intersect. And in this case, it should be right here. Mine doesn't. Oh, wait, I can move that. I didn't know that. How did I do that? There we go. Oh, I just learned something here. With respect to my iPad, I can rotate. Oh, guys, I learned something very valuable here. I can move that line like that. Okay, not going to worry about it right now, but that's good to know. All right, what you're interested in is where they touch, where the two lines intersect. And in this case, it should be at 1, 2. That's the intersection, and that is the solution to the system. Wherever the lines intersect is the solution to the system. It has to fit into both equations and work out. So, for example, if you bring this back over, let's check. We have y equals negative x plus 3. And we're using 1 and 2 as our values. So y is 2. X is negative 1 plus 3. 2 equals 2. It checks in that equation. Let's try it in this one. So y equals negative 2x plus 4. And remember, it's 1, 2 that we're checking. So negative 2 times 1 plus 4. 2 equals 2. It works in that one as well. So that's the solution. That's the answer to this thing. The intersection is the solution to the system. Okay. Now, in this situation, we only have one solution. So this is called an independent system. And you're only going to know that once you get the solution. If you just have one solution, it is an independent system, meaning there's only one point that will make this true. So this particular example is an independent system. Okay, I'm going to stop this video and we'll look at page 174 when we come back.